Hello and welcome back to Evening Rust with me, edA-qa mort-ora-y. Today we're going to tackle the game of wars. We saw it yesterday and I decided not to do it. I went on to another puzzle. We called it the Mars Crasher as the way we played it. We were not successful with it yesterday, and so we're hoping today we can solve war once and for all. And we're going to do it with Rust. And we're going to status, and hello Studiosi. Nice to see you back. We're going to try to get you a better performance today. I hear some of you had fun yesterday watching me on the Mars Crasher. Today we'll do war. Before we get started, let me just know for people that are watching for the first time, we're playing a game, so we're programming over here at Coding Game. I'm using Rust and I'm learning Rust. This is the 5th episode, or label number 4, and I just started when we started this, so some of it's tough going, some of it's it's getting better. And before we get started, we're going to bug these fine folks here. We're going to distract them once again. And I opened up the wrong files, so let's see. Well, I've got to throw my chat on top. It's getting stuck at the bottom. Visual Studio, which I've used for nothing other than this Rust thing. I'm just going to take the link today. Let's just do the German one as it is. Oh, it does say it's in German, Krieg. Krieg. I don't even know if this is proper German. And let's see, nicht. And let's see what's happening. Let's see what that says. Can't change it, but that's okay. And let's go over back and bug these people as well. My link's probably still there. Let's go. Alright. I probably don't need that. There we go. Let's see if we can get to come with us last time. If anybody is coming from Coding Game, thank you. Thank you for watching the show. Feel free to follow me on Coding Game. I'll friend everybody back just so we can build up the community there, people watching there. Otherwise, always follow me on Twitch or YouTube, and of course on Twitter. And let's get started what we're looking at today. Actually, before I get started, a big thanks out to Slavomir, who signed up for me on Patreon. Gave me a good boost to my amount there, and he watched the show on Friday, not the Evening Rust one, but the big O notation, or as he said, the big ugly square-like shape, and he's very much in favor of me buying a tablet so that in some future show I can actually draw an O on the screen. So thanks very much, Slavomir, I appreciate it a lot. And let's keep going here with this practice here. So as I said, last time we had Mars Crasher, and we failed. Well, we got 4 of the 5, and the last one required us to actually see 84%. The last one is actually going to require a correct solution, whereas I was doing like very, very rough estimates. I'm going to do those offline because as I said, it's not going to be fun watching me draw stuff on paper because I can't get the camera on it, and it's going to be a bit of hand waving and not so interesting math. So let's go to war, and we're going to solve it. And as I mentioned yesterday, this is actually, I have an interview question based on exactly the same thing, where it's a card game, and it's a simulation of the game of war. I don't call it that because not everybody's actually familiar with that name, as I found out. And I'm actually going to read the instructions to see if it's actually the same game or how much different it is, and then we're going to play it. There's no graphics on this one. Hopefully it's not too hard, and I'm going to try and do it the way I do in the interview. I'm going to try and structure this nicely because I want to learn the Rust structures and see how that's working. So alright, so let's give it a go. If anyone wants to say hi, and they'll say hi back. Otherwise, watch the show and just enjoy. So let's go with simple card game. We have to find out which player is the winner. Distribution of the war game. War is a game. Good. At each game, in unison, each player reveals the top of their deck in unison. You know, I've done this interview question like 40 times, and I don't think I've ever said in unison. I've always said it at the same time. Okay. This is a battle, and the player with the higher card takes both cards placed and then moved at the bottom of their stack. The cards ordered by their following values, from weakest to strongest. Okay, so they're going to be annoying, and they're going to give us 10, Jack, Queen, King, Ace. This makes it slightly harder. There's no 1 in my version of the game. I just say whatever, you have numbered cards. I just say numbered 1 to 52. It simplifies it. And these ones are going to the bottom of the deck. So in theory, this game can actually go forever. In my interview question, they go to a side pile. So the game only goes through one iteration, and there's a definite winner. Okay, if the two cards are equal, then there's a war. First, both players place the three next cards of the pile face down. Then they go back to step one, who is going to win the war. Several wars can be chained. As soon as a player with the wins a war, the winner adds all the cards from the war to their deck. If a player runs out of cards during a war, blah 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 blah, then the game ends and both players are placed equally. Oh, interesting. So it's not like the person with the cards left over, it's just done. Test cases provided in this puzzle are built in such a way the game always ends. Okay, I'm going to have to assume that. Each card is represented by the following suit: DHCS, 4H8AS. When a player wins a battle, they put the cards in the bottom of their deck in the precise order. First the cards from the first player, then the one from the second player. So it's not like the current player, it's always from the first player and the second player. For a war, all the cards from the first player, then all the cards from the second player. So with two stacks there. This game only has two players, it looks like. And in my variation of the game, I start with two players, and I actually go to a second one. The first refactoring is to add more players. With two players, we can simplify it, but we're still going to try and do it the correct way. And number of cards for the player, input cards. If players are equally first, pat. Okay, pat. Yeah, it's technically correct. That's not a common term for that, but okay. Otherwise, the number 1 or 2, followed by the number of game rounds separated by a space character. A war or a succession of wars counts as one game round. Fair enough. 3. ADC 3. 1, 3. Okay, so these are cards. Okay, so we read all the cards for the first player, then all the cards for the second player. Let's set this up as though we might have more players, and we'll do we'll create a player this way. And the hearts and stuff have no meaning. Does it have any meaning? No. So the suits are completely meaningless. DHCS. I don't see any value to the suits in this game. So we can just actually parse them as integers, and they have to tie. So there's absolutely no purpose to the suits here other than to make the parsing annoying. And the actually only annoying case is 10. And we're going to have a trick for that. Because there's no card 1, we can pretty much look at just the first number of each of these. And if it's a 1, it becomes 10. Otherwise, it becomes a number. And then we just map it across to the actual value. Okay, so let's set up the player. What does a player have? And I forgot my... they have a stack. And this is going to be a vec of, let's just say... Do we have to track the... We don't have to write out what cards they have. Which means we don't have to track, we really don't have to track the suit. The suit can be just entirely discarded. So we're just going to do a vector of integers. We don't care what card it is. We're just going to give them face values. The actual values are also completely irrelevant. So let's just say a vector of int. And there's also going to be a turn stack. These are the cards they're playing in the one individual turn, the one they've turned up. And we're going to put an implementation for a player. And I keep forgetting how this is done, but we have vector function new, and we'll just create an empty one, and this becomes a player, and that's gonna take ownership of it. So we just say player vec new, and I'm still uncertain of why this has the right type, but that's not my real concern. Vec new. You'd think there should be some type on the turn stack, on these stacks here, to indicate what type it is. So this will create the players for us. And we're going to have two players here. I don't know if you can actually... Can you create a static array of two players? That's a bit interesting. I wonder about that. Whatever. Let's just create 2 players. I'm going to stick them in an array because it's very standard. I'm just going to use a dynamic array because I don't know left mut players vec player equals vec new. And then we have to say players dot push vector vec. What is vec? What's the push for vec? Is it push? Push. Push. It is push. So the look at the it's not very helpful here. It just doesn't come up with the ones. Push, and we're going to do player new. We don't care. These are just, they don't have to have any identifying marks. Player new. Okay. And so we're going to read this in, we have to lead all these cards in. And they actually have 2 loops here. It's almost sad. They actually did the loop twice, so I'm actually going to reduce that. We're going to say the number of players, so let's just cut out the line card P1, card player 2. Just cut that nonsense out. And go for P and 0. And what do we say? Players dot. Is there a size? No size, no size. I size. Come on, size. How do you get the length of an array? Length of a vector? Vec. Come on, vec. This is really weird. They have nice docs when you can find them, but then they have like 3 with the same name, and you're left guessing which is which. And size. Capacity, who cares? Who cares capacity? Let's get the size function. Is there a length? Okay, where are we at? We need len. I guess len is the one we want. Length. Dot len. And we're going to do all this twice for each player. And we're going to add their cards. So we have a card P. The end cards of player 1. Oh, it doesn't. We're going to leave those comments. Doesn't matter. The number of cards. This is the nth card, I guess. Card P. And all we actually have to look at is the first character. And we're going to use a match. And let's see what this is. So we're going to say let C value equals match card P characters at 1. I really forget how to do that. Let's just say card P. Card P. And then for the match we have, I'm going to look at my syntax again. We have a match, and we just return a value. It's really going to be 1, and we said this becomes 10 because it starts at that. And for all these other ones, there are optimal ways, I suppose, of reducing this, but I'm going to have to do the map anyways for the special characters. So you might as well just pretend that they're all special characters, and then just forget about having a special map. 6, then we do 7, 7, 8, 8, 9. And the reason why we're mapping 1 to 10 is because it's the only card that starts with 1 and we're mapping characters. And then we have a Joker. Hey Sasha, nice to see you back. Okay, and we're going to map this at 12. Oops, that was supposed to be Queen and K. 13, ace, 14. The values are actually irrelevant because all we need is the same order. And so we're going to say players P dot push CV. No, sorry, dot stack dot push. And we're going to quickly write out the things here to make sure we have the right values. Print air. And we're going to say card P, CV, and pat. Fine. Let's see. I just want to get this compiled so far, and let's see what actually comes out of it. Vector field should be separated by... Alright, what am I looking for here? What's the struct? Stack should come. Okay. 61. What do I have here? 61. Need a semicolon, comma. Yeah, I think I got to the comma faster. It's unfortunate that the chat is delayed. You're gonna have to race me how fast I can understand the console output. Ignore me. I'm going to take somebody else's advice, the Rust community, and to use I32 instead of iSize. I actually read this. One of you guys posted it to me on Twitter, and there's this, I don't know, it's just this hilarious long issue on the Rust language about the choice of naming iSize for P in mid players. That actually sounds better for P in and mut players. That sounds wonderful. I hate doing len, and so we can just say P down here. Good things to learn. We have to take a slice of that and see if this compiles so far. See now? No, it's because I put a dot. I didn't mean to have a dot. I really didn't mean to. Match head expression, parentheses around, no parentheses around match. Okay, fine, go away. No character named at. End 0. There's probably a head or something. What's this? 48. Uh-oh. What does this mean? Found char, but it wanted an option char. Did I miss something in the case? Huh. Alright, so I'm going to have to figure out this one. I don't actually see what the issue is here. We have a match, and it's complaining at line 48 that it's expecting standard option, and it found char, but I'm trying to match a char, I think. So we're going to look up this one here. Oh, why would you make an arrow output where I can't copy stuff? That's like the stupid, if I let go it disappears. That's a poor UI decision. Now you have to highlight and... Alright, so I'm not getting a good reference, so let's go for Rust match char and see what we get for that. Match. What is this thing? Too much to read. So we have the match syntax, but I want to match a character now. Option T. None, some. I don't understand what it is. Some. There's an asref here somewhere? Where would I put an asref? I've got a character here. So nth returns an option. Got it. I want to explode the program. That sounds like more fun. So it's an option. I got it. Okay, so his error was that it didn't want an option. We had an option. Go away. 0. If that card's there, it's nothing. I'm just... because I really actually want to panic there, but let's do it. Okay. So we found an A14, king, queen. That's fine. King, queen. We found everything we wanted. In the example I was making. Okay, yeah, I am... yeah, I'm gonna... well, we're putting on a wrap here. And this here, if you know any better way for this, there's got to be an easier way to just get the first character of that string. But if not, we can just go... we can move forward with this. It looks like I'm getting the right values out of here. And each player has the same number of cards. And let's just see if the players can play. And I want to write a function here. Actually, just write out the loop. I think they have just a loop. And what do we do in the loop? The first thing, if p0 dot... let's write a function. Let's do this. We haven't done these before. Let's write a function's empty. Is empty. And can we use one of these things? I don't even know what this is. No, we just want to say this. I don't really know how this works. And self. We're going to return self.stack.len equals 0. Is this the correct syntax for this short return? I don't know, or do I have to stick it in brackets? Well, let's find out what that says. If this is empty, then we're going to print... no, we're going to break... we're going to do this. We're going to print... I'll do the redundant way first. It's a little bit weird. Player 1. And turn count. Break. Else if P... oh wait, this is silly. Now I can't use for the P and mut player because I actually need the count. If PI is empty. Now, here's something for anybody who asks, how can I break out of the outer loop? Is it possible? This break should break out of the outer loop. I don't know how, so I'm just going to return, just go away entirely. And this will be player I plus 1. If I don't see syntax, I don't know how to use it. This will work for now, so let's come to enumerate later. Let's go to do enumerate. I'll say Killer Cup says enumerate. Foo loop loop break foo. Labels, labels. Really. So let's do fruit loop. Break fruit. Fruit loop. There we go. You're saying that'll work. So we can break the fruit loop. And why fruit loop? Just because it's more fun than a foo loop. Okay, so we're going to go through this. We have the players. So we're just going to check the condition. If one of them has no cards left, they've lost. Now we have to start the turn, which I say let mut turn count I32. Let's just say equals 0 I32. 0 I30. 0 I32. Now we have to check the cards, and they're each going to take the top card of their pile. And let's make a function that actually does that. Fn top card n mut self returns. Well, I really don't know. It's going to return an I32. And there must be a pop function. Pop. Pop. Pop is good. Okay, and we actually want to pop this directly. I'm going to call it play card, because what actually happens is turn stack dot push. Do I have to say self? Yeah, okay, self dot stack dot pop. There was a pop, right? I just wasn't making it pop. And we actually need that card, so we're going to say let cv equals self dot stack dot pop. Or do we need it? We can just check the top of the stack. Yeah, let's just do it this way. We don't even want to return a value. We're just going to say this. We're just going to pop it. We'll push it to the card. So every time we play a card, we're going to play a card for both of them. So let's just play a card for both of them for I in 0. No, we do it correctly. For P. What was that? For P and mut players. Do I need the mut here if I'm not changing the players array? I'm changing the players inside of it, but not the array itself. P dot, what do we say? P dot play card. And we know there's no value 0, so I'm going to do it this way. So we're going to know who the winning player is, and let's just do it another way. Let's just think through it. Let's do a play card. They each play a card. And then now we're going to make the assumption that there's 2 players, because this is part of the game where it's simplified a lot if there's 2 players. So you can say let cdiff equals p0 dot turn stack, turn stack, turn stack, turn stack dot let's say turn card, so I can wrap up whatever nonsense I have to do in there, minus p1 dot turn card. And let's go write a turn card. Then turn card and self. This returns a self dot turn stack dot. Now what's the back? Is there like a back here? Back. Back? No, there's no back. Is there a last function? Last. And it's an option. I'm going to assume we're doing this correctly. We're going to do a turn staff dot last dot unwrap. We'll just let the game panic on its own if it runs out. Because if we ever hit the situation, we've done something wrong anyways. Turn card. And the special case here is if cdiff is equal to 0, but if cdiff is less than 0, then who wins? Yeah, I'd say if cdiff does not equal 0, I'd say 0. This is a tie here. Else somebody wins. And the winner is then let winner equals cdiff less than 0. This means player 1's card was higher, and ternary cdiff less than 0, then 1 else. Syntax? No, this is actually 0. Else 1. I keep screwing up the syntax, so when I go pray let's try again, it's going to really get mad at us. And so let's do... Okay, then we loop to the cards again, and I'm player 1. What? Okay, so I'm going to assume that with this enumeration is in order for P and mut players. P dot take cards T players winner. Sorry, players winner dot take cards from P. So we're going to take all the cards that person has, and we're going to let this run the first time without assuming a tie. We know this is going to break with a tie, but let's make it function cards. Yeah, I don't like when they say players or take cards. Yeah, that's why I made that correction too. So take cards and mut self. I have to do this then. Okay, well, there's no such thing as shorthand. Okay, that's fine. I just need to know. I hope Boolean's a type. No shorthand, so we're going to write it the long way. We're going to write take cards. This has no return type, so I guess we write nothing. Now I'm really hoping there's a function here that I can say self.take cards. This has to be another one, and mut other. Self-stack dot something. I want to do like push front, and I want to do other. That would be ideal. Let's see if we have such a thing. Push front. No. No push front. Place back. Push. Insert. Insert. So is there a way to... Am I going to have to insert every single one of these? Yeah, that's correct. Thank you. That has no return type. This has no return type. This one has a return value. This one takes that off. Good. Now what I need to do is I need to add all the items from the one array into the other one. And I don't know how to do that yet, so let's do this the long way for I in 0.other.len. We're going to do self.stack.insert I other.nth I, probably unwrap, and then other dot, this is other dot turn stack. Stop it, you stupid program. Turn stack dot go away. Stack, and there must be a clear or reset or something. Reset, clear. I'll assume clear actually clears it. And so I'm assuming, given the slicing functionality, there's some way to actually do this loop automatically. What I want to do is take all the cards from turn stack and stick them at the front of this stack, because that's what we said we do whenever you win. And at the bottom here, we do this in order. We take it for the first player and then for the other player. And otherwise, I'm going to keep continuing. And I'm just going to assume there's no, I'm going to assume there's a winner this way right now. So let's get rid of this thing. And we'll just try and see all the compile errors I get first of all. And line 41. Function take cards and alright. We should probably say what the other type is here. Takes cards from another player. Okay, and there's no other, that makes sense. 43, 45. Okay, 90. Did you mean I? Let's go down to 90. Players, I meant players I. Alright. Okay, we need to do 34. This unwrap's going to get annoying on me, but that's okay. $38. What do we have instead? Found type. That's weird. I thought the fundamental types copied. I thought I wouldn't need this. That's really weird that I need the reference to there. We want... And this syntax is getting weird sometimes. Immutable... Okay, 43. There is no nth here, so how do we find the ith item of a stack? We don't do anything. We just put the stack. I. We probably don't even need to unwrap that, which is weird. Now that I think about it. Let's find out. Not found. 91. And 99. We have an error here. cdiff equals players. I don't know why I have player there, players. Okay, and what do I have now? Unused variable I, is that a problem? I want to know why I have unused variable I, that's suspicious, 62. Is there any way I can ignore this? I don't actually use the variable I. Oh well. Alright, 41 is going to start pissing me off. We have... Cannot mutably borrow immutable field. Well, it keeps telling me different syntaxes, but I'm okay with that. Alright. Just ignore that. Now we have a problem in... Oh man, this is a problem. This is one of those fundamental limitations of Rust, and I don't really understand this thing, is that I can't do this loop here. Because I can't alias the players array. Yeah. So and this annoys me that I can't do that, because I could actually do this, can't I? No, because it borrows it again. How on earth do I do this? Without just hard coding it. There's no way to alias, so I can't actually... Does this have to be mutable? It does. I can do it in 2 steps. How do I do this then? Okay. Sakria? I think you guys can see what I want to do. I want to do a loop. So I'm really going to have to do something like this. Let's copy all the cards across first of all. I don't like this. And then I'm going to do this for P and mut players. P dot clear turn. I think that's the intent. Take cards is going to have to do something different than take cards P, clear turn P. So take cards cannot do that. I have to do take card clear turn and mut self dot turn stack dot clear, and this just becomes a reference to the other player, so it's not a mutable reference. That's going to fail as well though, because what I read is you can't take a non-mutable reference to something that already has a mutable reference. Yeah. How can I make a function that takes a reference to itself? Is there any possibility? It's kind of annoying. So this won't work either. And how can I actually do this? Then I need to, I'm fighting the language right now. I need to do something it doesn't want to let me do. Can I do that? How would I do that? I'm trying to think. I want to return a new player, take cards. Yeah, but I'm trying to encapsulate this. I don't want to know what take cards means here. So if we take the, as Killer Cup says, if we take the functional state modification approach, that might make sense. Where if I say players winner equals something like this. So this just takes self and it's going to return a player. Yeah, but I can't write the take cards because one way or another I need to pass a player in, and yeah, okay, I'm going to write the take cards approach. I'm going to take the approach. I don't like this approach. We're just going to avoid this. We're going to avoid the in because that creates a mutable array. I'm just going to do it this way. Players.len. This avoids any immutability. And then I could do player I.take players.winner.take or insert cards players I.take cards, and we can actually do it this way. So this breaks any mutability agreement. So this one here, the mutable references will all be gone, and it's going to return the stack of cards, and insert cards is going to return it differently. What do I call it? Insert cards and take cards. Okay. So now we're going to do... Now we have take cards. Let's do insert cards. And this takes the mutable self. And it takes cards. And this is a vector of I32. It can just take ownership of it. We don't care. It returns nothing. And we don't know how to do it, so we're going to do for I in 0.cards.len self.stack.insert I, comma cards I. And take cards, what does take cards have to return? It doesn't return that anymore. It returns a vector of I32. And it takes a reference to self, mutable self, because it's taking the cards. And do we duplicate? Can we clone something? Clone. Clone. Just a normal clone. How do we clone a vector? You know, it probably doesn't matter. Let's do it this way. Let Q equals self.turnStack. We're going to take it. We're just going to steal it. Self.turnStack equals vector new. We'll just create a new one. And then we're going to just return Q. If this doesn't work, we'll do clone, but this should also work. And this is probably cleaner. Rather than like cloning and then clearing, we just give it the old one and create a new one. Defines here, insert take cards. Yeah, that's fine. So Studioso says, I'm going to read out loud, this kind of trouble is what I'm continuously getting into encoding Rust coming from more traditional language, and it's discouraging me very much from learning Rust. The curve is steep with ownership, mutability, etc. And this is, my initial feeling is kind of the same. And let me explain why I'm actually taking such a careful look at Rust, is that this ownership is one of the main reasons I'm looking at Rust, so I want to solve this. And as I mentioned, this approach here, this restriction here, this is basically a functional programming approach where you're not allowed to modify the objects. And it's forcing you into that pattern where you return things. It's forcing you to unwrap the way you're modifying, and it's discouraging you from modifying state in an unpredictable fashion. Now, the reason I think Rust does it is they're trying to fix data races. I am yet unclear as to how this fixes data races, but I'm hoping to get there. At least if I can code this way, I'll be able to understand data races. Okay. just ignore that comment. Cannot move out of borrowed content. So we have another Rust rule, a Rustyism. Why can't I do this? I don't want a reference. I want a new stack. I just don't care. Clone. We're going to do the state-based approach then. And I'm ready for this one out. 113. What is it complaining about this? First borrow ends here. Second borrow here's first. No, that's wrong. Wrong, 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 wrong. I disagree. This isn't borrowed until after these are evaluated. Okay, I disagree with this from a language perspective. If you have let Q equal something, and I put Q down here, my feeling is that it should be the same as sticking this directly inside here. But apparently the argument evaluation in Rust is a little bit different. It's actually evaluating the borrowing here before evaluating the parameters. I find that unfortunate, but it's something to deal with. So we're going to have a lot of the let here. Yes, this for loop here is already prevent evaluation. Non-lexical lifetimes. Oh, so Sequoia, are you saying that I shouldn't have to do this let Q anymore? That if with this fix I should be able to put the players take cards directly inside here? If yes, that'd be great. Okay, in any case, we're going to do a turn count plus equals 1. Let's see this at least survive one of these tests. Alright, so... Okay, so, but I'm happy to know that it's not just something that bugged me, it must have bugged other people as well. And it bugs me because I've spent a lot of time in Leaf trying to get this exact thing working. I can totally understand why you want to be forced to do this. And no, that's okay. And I know it's very hard to get this to be exactly the same as putting it inline. And it is kind of annoying. You do prefer the syntax. I can deal with this for now if I know it's been fixed. Alright, so we're going to see how many of these don't have a war. So this code should work now as long as there's no wars, as long as there's no ties, which I'm assuming is going to be the second one that fails. Second one succeeded, so their tests aren't really that adventurous. Okay, and this one probably means we have an actual failure here. The fact it took so long probably means there's a war here, and I should have gone through the war. And so now what we're going to do is when there is a tie, we're going to do the war, and we're going for each players for P in and mut players P.play card. And we're going to do it 3 times for I and 0.2, 3. We're going to play 3 cards, and then we're going to do the loop. So at the end of this one here, we're going to break out, and I'm going to put another loop here. And we'll get back to whether the turn count has to be updated or not. And if the player can't play cards, let's see first if that handles it. Okay, yeah, so one of the players probably couldn't play a card. So let's make play card return a value that says bool. And if self.stack.len equals 0, we return 0, or false, return true. If not play card, then by its definition we're supposed to say print line pat and breakthrough. Just get out of this whole thing. We're done. Okay, so we screwed up. We're going to have to figure out what these cards are first of all. We ended the game at least, that's good. So we play 3 cards for each player. If they can't end, it fixes. So what do we have? We have this loop here. We have this fruit loop, which is the outer loop. And it just keeps playing the whole game. And I should put this in a function, but I just don't want to. Sorry. It's not very well structured to see. And now I want to do... So yeah, this should really be in a function to make it a lot clearer. But this turn count makes it a little bit more complicated, and I don't know the structures well enough yet with this mutability, how I'd be able to do this all inside a structure. So I'm going to stick with this little bit yucky looping for now. And we have to figure out where the break is. Let's logically try to debug it first. I said pat when it was supposed to be player 2 that wins after 56 rounds. So the first thing we say is we didn't hit any of these connections because it didn't. No player card is empty. So we played a card. We wouldn't get. All right. If you can't play a card here either, which is in the case of a war, you're also going to end. But that's obviously not why we're failing now. But it's a condition we have to check. And so now we check the 2 cards. Let's double check turn card. So when we play a card, we push it onto the top. Good. Turn card says last card unwrap. That's correct. That's the one I'm supposed to be looking at. These cards are face down. It makes no difference. Nobody's looking at this. And that's if it's the same card. And okay, now we have to figure out what's logically wrong here, because that seems to be about right. Each player plays 3 cards. 3 cards face down. Then they go back to step 1 to decide who is going to win the war. Several cards can be chained. As soon as a player wins a war, the winner adds all the cards from the war to their deck. First the cards from first player, then the cards. That's correct. Okay, we followed that. Now, what are we doing wrong here? Anybody know a quick way to print the players? How can I do a join? Is there a way to do it? I want to do a print error. P0, and I want to do player 0 dot stack join. Anybody know how to join these all into one big old list? Rush join array into string, or join back into string. Well, this looks reasonable. Connect string list connect. I guess connect works. Dot connect. Come on. So we got to figure out now what the problem is with these cards, because there must be a logic error, but okay, if fine, we don't need parentheses around if conditions. Neither do we. Will that join the arrays? Comment from Killer Cup. Derive debug. Let's see. I want to see this work. That would be really helpful. Print error. Players. Let's see what this does. Woohoo! Prints cool stuff. Doesn't print isn't the easiest format for us to read. Okay, so what was the first thing? You can't scroll this. Okay, I'm going to need to do this in 2 lines. I'm going to do it this way. We need to see this on 2 lines, and excuse the duplication here. I'm sure I can just put that all in one with line feeds in between them. That's clever. Let's see. Whoops, no, that's no. That's going to make it hard. Okay, so we want to actually go back this way. If you know a way to do this one, you seem to know Rust better than any of us here, Killer Cups, so I want this output. If you know how to get this output better. Okay, so stack player as a... So this first player, at the end, let's check the start. After every turn... Player 2, I have a hard time seeing their win. Get a 12. We're going to have to debug this every single line. These are hard things to debug. There's so much data involved. Player 1 was winning the whole time, up until that last little bit. And how on earth can I tell at which phase we went wrong? Let's try the first one again. We're still good there. Still good there. Alright, let's do it an ugly way. Let's do it inside the loop. Everybody inside this loop. We'll have lots of outputs. Turn stack. 8-5 golf. 8, they both have that. And he has no cards left. Okay. I want to see exactly this output, Killer Cup. I just wanted the 2 players in 2 distinct lines so I can compare them visually. That's why I just put it in 2 lines, assuming that works. Otherwise, I want I just want expanded 1 level so I can see this. And I've been reading these ducts and rust, and they're actually okay. Again, as soon as you can find the one you want, they're okay. So this is very hard to figure out. Where did we go wrong? Because at the end of a war, we take another card. I mean, very, very clearly. Go back to step 1. Weakest to strongest. Good enough. I don't think I have a problem there. The 2 cards are of equal value, then there's a war. First, both players place the 3 next cards of the file face down. That's what we do here, 0 to 3. And we see we have the initial one, which matches, with 3 following it, so 3 more junks. And in the turn before, we had 8. Okay, now this might be here open to interpretation. Do they keep their order when being placed face down here? Right now what I'm doing is playing their orders on top. Do you think this makes a big difference? This would be kind of annoying if it did, but it might. And it's the only thing I can see that we're doing different at the moment. Let's see if they have an example. Not a really good one, at least. So there's an ambiguity here, and I'm going to have to assume at the moment that we have the ambiguity wrong. It's that when you place 3 cards in the pile face down, so there's an ambiguity, like I say, in which one's actually where this. I don't know what the order of these cards is. It's not clear for me what the order of these cards is supposed to be. Face down. Then go back to step 1. Who is going to win the war? Okay, so we're going to invert the order. So we're going to make play card take a number instead. Anybody know how to do optional? So I'm going to play 3 cards. Play card 1. So play card, I'm going to take count I-32. If stealth that lang is less than count, then we fail. Otherwise, we're going to pop off. We're not going to pop off. We're going to keep inserting at the current index and let end equal to self.turnStack.length for I and 0.count. Self.turnStack.insert at end. Self.stack.pop. Did I do this right? I want to inverse the order so they maintain the order. If you pack off 3, they go directly on the next stack 3 in order. If I take the last one, I put it down. Yeah, that should keep the same order. Oh, come on, give me a break. Whatever. I can make one of these as eye size. It doesn't make a big difference. We don't have it in our program. And this is one of the reasons why I prefer just using integers everywhere. And I think they're making the same mistake C++ did by making these things unsigned. Is it makes it unusable for basic integer operations, and it's the reason why a lot of other languages chose just use integers everywhere, even for sizes, even for things like length that can't be negative, because otherwise you have type conversion errors a lot. No, we're still wrong. Now this is going to be very, very hard to debug. We have a different output, but we have to figure out what on earth is the problem here. Does any of this make sense? Let's view this output here a bit more. Can't view much more. Okay, so this line only goes one way. I'm going to be debugging this. So the turn stack, that looks fine. Both stacks are empty here at the start of the turn. This is correct. Let's make this very clear. And we're going to do this right here. Print error start turn. And then right here we'll say there's a war. Print error war. Now let's see what's actually going on here. Okay, so we start the turn, and they both have these cards. And their turn stacks are both empty. And then when they play the turn, it goes to war, and after that war, we would expect from him 12. No, we expect this will be in the bottom. What do we have? Where's the 9? Yeah, sorry. We're checking the end. Sorry, it comes from the end. So you have 9, 8, 5, 13. That's what we're expecting now, because we said these three maintain their order, so they maintain their order. They go face down. And then player stack here, his comes from the back 9, 7, 12, 2. Okay, so all I did was reverse the order from before, but apparently that's not good enough. Apparently that's not the way it works either. So now we have to look for, I don't think we have an error so much as, and this is supposed to go a lot many turns. So let's see with the third and the fourth one, if we get anything better. This one fails a lot quicker, which makes a lot more sense for us. It's a lot easier for us to have check this one. Expected player 2 wins. So they start with 8, 13. They start the same cards. And the second turn, so there's a 3 and a 2. And whoa, 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 whoa. Check this out. Is this supposed to be 3-2 or 2-3? When a player wins a battle, they put back the cards at the bottom of their deck in a precise order. First the cards from the first player, then the one from the second player. But I believe that's what we're doing. So in this first case here, well, except for the fact that he shouldn't have gotten any cards because he lost. So that would be the problem there. The order's not the problem, but the second player should have won there. So we have some issue here. Winner, who's the winner then? So we screwed up the winner. Winner equals winner equals 0. That's not good. We don't that. With what was the C diff? Do I have my comparison backwards probably? Diff. Come on. C diff. Card diff. -1. 2 minus 3 is -1. That's correct. No, yeah, okay. That was back. I think one of you corrected me on that before. Maybe I screwed it up when I didn't fix it. We still fail, but let's see if the first ones win. No, we're wrong there. Winner equals 0, because the difference is 1. We have 12 and 11. That's correct. He wins, and he ends up with the cards 12 and then 11. Then player 1 still wins, because it's 13, 12. And he ends up with the cards 13, 12, and then 14 wins. And the winner... I'm getting confused here. We have the C diff is the cards, the first player minus the second player. So in this cards right here, if we took this turn card is 12 and 11. So it'll be 12 minus 11 equals 1. Which is correct. 1, and we're saying here if C diff is less than 0, which is not, then the second one, otherwise player 0 equals win, and winner equals 0 is what we want. Winner equals 0. The diff of 1. But why was this working before? Now I've made a mistake, and I want to figure out where this card's going to. Where inner winner is 0, take cards Q. We're inserting these in the right order. It says always start at card 0, player 0 first. And then all the cards from the second player. Alright, I think we might be screwing up the input parsing. What is our input? Cards of player 1. What does that mean? Okay, we have another ambiguity in the description here. When doesn't say what order these are in. Which is kind of annoying. That is, we don't know if this is actually push or insert. So let's just try the other way then. Oh, that goes a long time. That's probably not a good sign. Oh wait, why did that take so long? Wait, did I just screw something up there? What was it complaining about before? Expected 1-3. What am I printing out wrong? I'm printing out the wrong winner. I'm printing out the wrong winner. I'm printing out whoever's guy's deck is empty. These are the losers. Alright, we're going to take advantage. We're going to screw the multiplayer support. Let's just get rid of this for a second. Is there an easy way to do this? If player 0 dot is empty, then we'll print line. Actually, this is 1. Then 1 wins with a turn count. Else if trying to get too clever too fast, exactly what I tell people not to do in my interview, and I screwed it up. Of course, my interview I'm quite happy. I don't actually run the thing. If it looks like it works, I just accept it. Okay. Expected 1-3. Sorry, this is not. 2 and 1. Indexes are all backwards. I hate 0 and 1 indexing. Found. What? Expected nothing. Alright, yeah, we had a grapefruit. Where's that key? Alright, good, that one works. That one works. That one doesn't work. This one had an easier one, shorter. Okay. What didn't work here? Expected 2, 1. On the first turn, they expected a whole bunch of words, so that's going to reveal a lot to us. Okay. If they're expecting the first turn to be a war, that means we are reading the deck in backwards. This has to be insert 0. Now we're just counting wrong. That's fine. I think it's because the turn count is out here. Let's see if any of them fail now. Okay, one of them fails. Oh man, it's getting annoying. So we have Pat. What's it supposed to be? Pat is supposed to be Pat. And like, look at these test cases they give us. That's just mean. And I'm getting kind of annoyed at this one. Winner is 258. 1 minus 7. 258. The reason I'm getting annoyed is because the description is actually not accurate. We don't actually know from the description whether I'm inserting the cards correct here. I don't see any reason why this shouldn't be push instead of inserted 0. That's question number 1. We could be wrong there. The second case here is when we play cards. In this play cards function, we don't actually know whether this should be an insert at the end or whether it should reverse the order again. And so we have another variable here. That is, the other option here was self.turnStack.push, self.stack.pop.unwrap. So this is another legitimate option here based on the description. Let's try it with that description instead. It doesn't work with that one either. But that one works. And so that kind of annoys me that we're fighting here in ordering in the documents that it's not clear enough as to what order these actually go in. So if I play them all in this format, and it's kind of stupid that their first few tests don't care which the order is. And so they actually have a specific test checking a very specific ordering, but then not being specific enough in their docs as to what that ordering is. So let's try this again instead, pushing them on the back instead of doing it the other way. And so that one fails. But you notice when I switch these back and forth, something fails each time. And so it's quite possible when we're sticking the cards in the bottom of the stack, we're putting them in the wrong way. Okay, but that one doesn't care there. Right, so we have one other option for the insert cards and take cards. We could be doing this one wrong as well, but it says stick it at the bottom in the order of 0, 1, and that's what we do. We take the flares from the length, and we take the cards from the first person and stick it onto the winner. And we do that in all the cases until all the cards are gone. And the only way we break out of that is, this is where we break out, otherwise we just keep stacking on the cards. Play card, play card. And the only case we have that fails is a really long one. Okay, that was working before, wasn't it? So we'll go back to insert. This got us further. Oh, that one's still failing anyways, so play 3. Or that one was failing before, wasn't it? Did we have that one working before? Now we have a whole bunch failing on us. I think this insert made more sense. Which one failed? Just the long game? I'm going to play them all and see which one fails, and we'll debug that one. Okay, let's try Pat, and let's see why it thinks it should upset this one. So Pat says we start with this deck here, and this is like, how do I debug this? We have all the other ones, and we come out with a winner, and they say it should be tied. And I would actually have to track through every single one of these steps. But so far I think our logic is fine, so... Alright, so winner is 0, 1, so at the end of the stack we had 5 and 4, and we have 5 and 4 stuck there. And I see no ties here. How could it be a Pat if we don't see any ties in the input? We have 4, 5... There is one tie down there. Should we have gotten to it? If these are the same length, and I don't know if they are, they look like it. There is a tie of a 12 there, and an 11. There's also a tie of an 11, and a 9. Yes, I have that condition here. When we do the cards in the war, I have if not play cards, we print out Pat, and we're done. So I have that condition covered, and I also have it if the next card is gone, it also plays Pat. And so what I'm looking for is somewhere in here we have a screw up. This is a bit weird here. Why is this printing ... Okay. Something here has gone awry. We had these normal stacks here, and then this one became super long. Yet there is nothing in the... What? Huh? Why? There's something wrong with our take cards, and I don't understand what it is. So we might have a rust issue here, because we had a proper player stack. And then suddenly this one grew out of control. The second player suddenly took a whole bunch of cards from somewhere. So let's see how many target cards they take each time. Take q.len. And let's try that one again. Yes, I meant print air. What is this? What on earth is ... Anybody know what the ... stuck in there is? 11, 8, 14, 12, ... 13. They only take one each time. But something's gone horribly wrong with our stacks here. You can clearly see it. Something's gone horribly wrong with the stacks. And I think we've done something that Rust was supposed to protect us against, is that we've modified the stacks incorrectly. So what do we have? We are allowed to do this. Take Q. Try that again. That's fine. It's always taking 1. So winner equals 1. He's supposed to take 11 and 8. That's fine. Winner equals 0. He's supposed to take 10 and 8. Took 10 and 8. But then the second stack is destroyed. I don't get this. What went wrong with the second stack here? Turn stack. Something broke here. And where does it break? Let's do this. Yeah, I'm assuming that, but I'm not understanding why this suddenly got too long, because on this step, we have the winner's player 0, so player 2 shouldn't be getting any new cards, and we actually see player 1 getting cards, but somehow player 2 is getting cards. And I don't know how they're getting cards. There's cards being inserted here that just too long. And so let's do another debug step here. And do the 2 players out again right before the cards. Do you mean it's truncating my entire output stream? We can test that too. If we say turn count. Okay. It is. You're absolutely correct. Wow, this makes this almost impossible to debug. How am I supposed to test it? I don't know how to test that. Let's see if there's a war. Let's take out the printing of the players. Let's take out the start turn. Let's just take the winner and see how much they take. Let's see if we get any less output. There's a bunch of wars here. War, take. So it doesn't truncate anymore. It's a long game. And without being able to print it out, I really don't know how I can debug this here. We have 2 test cases that fail, and the rest that work. No studio, so I think it was just before when we're doing that, the output just wasn't long enough for it to truncate. It's because of these ones here that is long enough that is truncating it. And it's just because everything up to there. And so I'm struggling to figure out how I would debug this at this point, whether I really want to. Because we've already identified that based on the description of it, on lines 100 and 101, I cannot identify from the description which one of these is correct. The second case is from the description. I cannot identify whether 40 or 41 is correct. And we see some of them win and some of them don't. And in the worst case here is I can't entirely certain. There's a forum link. Where's that? Check that out. Okay. It seems like they had a lot of the same questions. The order of face, the winner always takes the cards from player 1 first, no matter who won. Does that make sense? So he just tried inverting it. I don't... Alright, Killer Cup. Sorry we couldn't solve this, but I'm not actually sure. I don't want to read through this whole thing. Alright, this is too much to read. I'm going to go do another puzzle because I'm not convinced there's something we're missing in the rules, because we covered a lot of test cases. And I said we already identified 2 ambiguities, and there's a potential third one here. And we have no way to debug the output here. So I'm going to submit this, and I'm going to move on. It's no longer interesting, and I have nobody to ask for actual help on this. And yeah, that's the case I have covered. Yeah, that case is actually covered in the code. I say if anybody can't play cards during a war, or even the card following up, it's a pat. I covered that. Now this is very interesting in their actual results, as we actually pass more tests than we do in their test cases. Whatever. And I'm not allowed to give a rating. It's weird. Whatever. I don't care. That one bugged me. I'm going to go and do something else. If you change your code to give the players the cards from the first war, then the second war, and so on, it should work. That's what I'm doing, though. I'm putting a stack of cards. So they first play the card face up, then the 3 war cards go on top, then the other card goes on top, and then the cards go on top of that. And I stick them all under the pile. No, that's another ambiguity. And in this description clearly said you take all of the cards and stick them on the bottom. I don't like that one. I'm giving up on that one. Because, and I'm not allowed to complain about it, let's find one with graphics. I want one with graphics now. I'm tired of wading through these silly ones where there's descriptions wrong. Let's find one, view all. Memoization, that sounds like fun. Is there graphs? Last Crusade, I want graphics though. I don't want graphs, I want graphics. This has graphics. Good success rates, solve it, lots of stuff. Indiana's trapped in a tunnel. Let's do this one. Let's do something more fun. And your objective is to write a program capable of predicting a route Indy will take on his way down a tunnel. Indy is not in danger of getting trapped in this first mission. Okay, that sounds good. We're in no danger of getting trapped. Tunnel consists of a patchwork of square rooms of different types. The rooms can be accessed and activated by computer using an ancient RS-232 serial ports, because Mayans aren't very technologically advanced. Well, if I get this one done, we can do the puzzle of the week. Let's see how hard this one is here. Okay, 14 room types. Upon entering a room, depending on the type of the room and Indy's entrance point, top, left, or right, he will either exit the room through a specific exit point, suffer a lethal condition, or lose momentum and get stuck. This room type is not part of the tunnel per se, as Indy cannot move across it. Alright. These are the possible paths to the room. These are the possible... Please, oh god, this sounds complicated. So I just have to say where Indy goes. I don't have to determine the path through the forest. I mean, to the maze. Okay. Top, he enters on the top. 1-0 from the top. The outputs will be in 1-1. So 1-1 from the top, he's going to be in 0-1. And okay, I think this one should be straightforward enough. We have all these types, and we just have to map where they are. And we're going to assume he doesn't get trapped. So we have this grid somewhere. Each image represents a room of a given type. And let's make an actual struct for the... I'm going to start calling this a matrix struct. And internally this has a... what are these? It's a... rooms, and he's just going to have types to them. It's a vec of I32. Impl matrix. And we're going to create a new one here, so we're going to say function new, and this will take an x size I32 and a y size I32, and it will return a matrix. And this just becomes matrix rooms. This actually has to have a size. We need to have a width I32, height I32. And the rooms will be vec new. Oh, how do we do that? How do we initialize the capacity of it to 0? Doesn't matter. These are probably defined in order, so let's just go with it that way. Width is x, height is y. So we say let mut rooms are a matrix. I guess we can do it this way: matrix dot new width comma height rooms dot push Hey, it's never made us actually parse the individual lines before. Fine. So for C in line dot characters, what? Space separated integers. So we actually have to learn how to parse this time because it's space separated integers. There must be a way to split something based on spaces. So split string split. I don't know what that is. Okay. Split. Where's a split? Split collect. We don't need to collect. We just need to split. Is there a split white space? Let's see if there's a white space function. Split white space, excellent. That's simplified. Split white space gives us an iterator line dot split white space. We'll iterate all of these rooms, and they each give us an integer, and we need to know how to we're going to parse input in each one. I don't really know what that function does. It's part of the input one, so we're going to parse input C as I32. And that should parse it so far. I just want to see what error I get. I didn't get an error. So I might have actually parsed something. And so for each line, we just want to know for each type where is he. And inputs. So we have to get the room type here. So our room type. And we're going to say rooms.get xi, yi, because I'm not sure what position is. Top, right, that's top, okay. And so we get the room type, and let's go there. Call it get. And this is going to be an I32 because I'm going to return the type. And I'm doing it in the, last time I did the structure, the matrix, I did it in a, just inline, but I think we should start building this matrix class because it seems to come up a lot, like every single puzzle has a matrix, so I might copy this out to my code afterwards. So what we want to be doing here is return rooms y times, we need self here, and self.rooms y times self.width plus x. Okay, we don't need the return, we can just do that. So we have the room type, and what do we need to do? We need to know for each room, depending where it's coming from, we have top, left, or right. And this is just a whole bunch of statements. There's probably a way you can encode this, but let's just do this with a whole bunch of statements first of all. So if we have type 0, we don't know what to do. Okay, so let's just do a match, and a match, and a match, and a match. Let's do match room type. And we're going to make these both mutable, and we're just going to output them again, because it's always going to be related to the current room. And we'll output the end, the modified value, xi, yi, match room type, and we have room type 1 does something funny. Funny by means I don't know the syntax. In any case, yi plus equals 1. That's all that happens in room type 1. Room type 2, we're going to assume this stuff is valid. I'm not going to cover invalid cases, so if position equals left, then we say xi plus equals 1. Otherwise, we'll just do it the other way. Xi minus equals 1. And we guys got through all of these things. 3, again, we're just going to assume we have the correct entryway because he said it can't get stuck, so there must be a harder version of this puzzle later. And so 4, if position equals top, xi minus equals 1. Sorry, we have an error on these things. No, that's correct. If he came from the top, it goes to -1. Otherwise, we assume it's correct, and he goes to yi plus 1. Incidentally, coding this type of stuff in a table is actually rather difficult, but we could probably do it at some point. I just don't need it here. Position equals top xi plus equals 1, else yi. And the assumption that indie never gets stuck makes this a lot easier for us. And if position equals left, because this is basically the same room as type 2 then. Seven, 8, 9 are all the same type 2, so we're going to have to come back to this later. And I wonder if we can keep this code around. Can we do multiple conditions? 7, 8, 9? Let's find out. See what compiler error gives us, because here is just yi plus equals 1. And type 10 is xi minus equals 1. Type 11 is xi plus equals 1. 12 equals 12, 13. Oops. Losing my voice. Become yi plus equals 1. And I'm missing something somewhere. This is a really big, long, ugly statement. Match, 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 match. Okay, good. Unexpected token, 971. Unexpected, oh yeah. Duh. Wrong language. Okay, line 101, where we have that, line 101. Well, that's weird. I get an error here, but nowhere before. Ah, because I missed a space. Good enough. Now what do we have? Expected 1 of line 108. This is the one I expected. I don't know. I don't know how to handle multiple cases. I'm guessing there's an advanced version of indie where he does get stuck. And we'd have to take care of these anyway, so these would all be different cases. 7, 8, 9. Okay, I'm going to go back to that. That sounds better. Thank you, Sukiya. Now we made an error. On line 32, we did something, of course, as you says. Just assume it's in the right place. Non-exhaustive patterns. And that's fine, because if we have something we don't expect, we're just not going to move them around. We won. We didn't get to see anything, though. Yay, I win. Okay, so we're going to play all of them and maximize it. That goes relatively fast. It's because I have it on super speed. Oh. Let's watch the last one again. Just to see it at least once. And this was relatively straightforward because he doesn't get stuck. He's taking some impressive falls. Woohoo! And we win. So this is not very exciting code. But it's not going to get much more interesting if he gets stuck. What's interesting for us is we created this matrix, And I'm going to start copying all this stuff out because I see a pattern of more stuff coming. No, just leave me alone. And where are these things? We're going to create a folder here too. Actually, I'm going to put this in a stream folder somewhere. I don't know. Just leave it here for now. Coding game. codinggame.com. We'll call this one indie.rs. Okay. I'm saving this because I feel like indie's going to come back and I don't want to write this all again. And in particular, we have this matrix, and we're going to start creating a matrix class that we're going to cut and paste because all of these things seem to use matrices. So let's submit it. And, oh, we've reached a new level. That's wonderful. Let's go for it. Let's Twitter this. We love this. And, you know, this one was just okay. And the reason was because that's a big, ugly if statement. Not that much fun to code. And game of the week. Sasha. What is the game of the week? Do you mean this one, the CUNY contest? It's number 2. I don't see anything else labeled game of the week. There's a... So, game of the week. Anybody know? Online we have community contest. We could do that. Collected and practice community puzzles. This puzzle of the week, Minesweeper. Alright. Find the hidden mines in the grid, knowing that I think we're going to find our matrix thing again useful. We don't know anything about that spot. Curious. Before I start this, somebody did a research paper about this, saying that the correct solution for Minesweeper in all practices is actually an NP-complete problem. And they reduced it to the binary satisfiability problem by making all binary satisfiability problems reduced to Minesweeper, proving that it would be an NP-complete problem. Which, if this is difficult, given its complexity, I'm assuming we don't have difficult ones. We're going to have to assume easy ones, because it involves otherwise a ridiculous amount of backtracing to solve, and it's actually, it would take forever. I mean, on anything more than a simple size could take forever. So what do we have? The input line of size grid, blah, 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 the number of hidden mines, NB, H, following lines, content of the grid made of, lines, location, in a column ascending order, then a line in ascending order for the same column. Okay, so this is worth 50 points. Yeah. We're going to assume, and this is exactly what is said, that the inputs are specified in a way that we don't have to solve the binary satisfiability problem, and what we're going to do is the straightforward generation, is that when you look at the inputs, we look for anything that has a 1 beside it, and you look at all of these things and you say, look, these are all 1s, so I know there has to be a bomb right here. And then you keep going with that, and you keep checking every single one, and you hope that you never have to make a decision, because if we have to make a decision in here somewhere, the game gets not just a little bit harder, it gets exponentially harder to have to make a decision. So, I mean, they're not even parsing the lines for us anymore. That's just mean. Okay. So let's go back to our matrix class. Look at that. We're going to take this one again. I'm going to post that in right here. And I32. I can use I's because I have the number of bombs. And what's a question? A dot means... What does a dot mean? 0. Alright, so dot just means 0, it's just a special encoding, and question means question. So we'll use -1 to mean that. And these all have adhere to line inputs, and these have a simple series of lines, so we're going to do the exact same thing here. Let mut grid equal matrix new w comma h, and for C in line characters, are these space separated or content of the grids? Nope, they're not space separated. And this one goes up to 8. If C equals dot, then grid dot rooms. Let's actually extend this even more. Function push, and we'll assume this is generating an order. Not the safest assumption, but we know that's how our input comes. And we'll give it a value. I don't know how to use templates yet, so we're just going to keep putting the values this way. I'm going to say a hard-coded rooms.push x. Bad name now called rooms, but that's okay. Grid.push 0. Else if C equals question mark, grid.push -1. We'll use a marker that way. I don't want to get into the variant types and how to do this yet. Else grid.push C as isize I32 minus 0 as I32. And that should be the ASCII conversion, and that gives us our grid. So we have all the rooms in the grid. Now we're going to have to keep going through this, and for every cell in the grid, starting with the 1s, we're going to want to find all the 1s where there has to be something nearby. And this is only worth 50 points. This is actually quite complicated. This might take a while longer than you might expect. But we just have to go through all the rooms. nb.useSize. Why do we need to know the number of bombs? What is this NB? Lines including mine's location. The number of hidden mines. Do we actually have to know the number of hidden mines? Oh, we have to output them in order too. That's just delightful. Yeah, that makes it really annoying. Okay, that's fine. So how do we mark them as bombs? We're just going to mark through them as bombs. How do we want to mark them as bombs in the grid? We're going to have to find another way to mark the thing as bombs. And I'm just going to keep using I32. We can say -2 is a bomb. Constants probably do that, but let's just say -1 equals unknown. -2 equals a bomb. Because then outputting at the end, we simply just go through in column ascending order, then in line ascending order for the same column. So what they mean in the end is, so if we have C and 0 dot dot grid dot width. Yeah, but it's a weird output because I don't have an NB. Yeah, that's... Thank you, because I'm just going to go through the grid with this way for R in 0 dot grid dot height. If grid dot get, what do I have? I have x comma y. So C comma R equals -2. We said that's a bomb. Wonderful notation. Again, I only use the shortcut of -1 and -2 because I don't know in Rust yet the easiest way to set up variant types and enums and how to set this up, and I don't want to complicate it too much already. And we'll just say C comma R. But now we just have to find all these bombs. Simple, isn't it? And this means scanning through the grid. For every time there is a 1, we have to look around and look for the bomb. And is there a simple way to do this? Well, what we could do is look for the places that are unknown. That's what we want. We really want to look for the places that are unknown and then scan around them. And if an unknown has a 1 around it, it means there has to be a bomb there. And did you say this was funny, Sasha, or fun? Without doing a flood fill algorithm, how can we actually do this quickly? And finding the 1 case is simple. Alright, let's just... Thanks, this is how I want to end. I want to have another one if they want. Let's do the ones first. This is logic. I didn't want to do logic. So this is the output, print bombs. I'm going to put a comment for one thing. We have this grid here. We can actually make a function that works on the grid. And let's do function find bombs. Find bombs. And it takes a grid of and mut matrix. So I'm going to start creating functions here. You can thank Sasha for the choice of this puzzle. If it seems hard, just testing my... It's not a knowledge of Rust, I think. So we find bombs, and this should be an and mut grid, I think. And mut grid. And we're just going to go through all of them here first of all. It's the same basic loop. We're going to start with the loop, and if it's a bomb, what the number is, so let q equals grid.get c comma r. If q does not equal, we said -1 if it's unknown. There's got to be a way of constant, but okay, continue. Just skip everything of that style. And let's say let max equals grid.getMax. Max or min? How do I want to do this? Yeah, what I'm going to do is every time I place a bomb, we're going to go through, and every time there's a question mark, we're going to figure out where it is. And then we'll reduce the stuff beside it, and then we'll get rid of the bomb, I think. Because that one accounts for the bomb, and so we're going to start counting down the grid each time. So every time we place a bomb, we can count down the numbers beside of it. And that leaves us with the numbers that we don't know. Okay. But we have to figure out where is the bomb if there's a question mark and there's a 1 beside it. Because we say there's no bombs right now, You know what? If it's outputting this, the question marks, we'd almost have to assume there's at least... Huh. How do we know where the bomb is? I can just look at this and I know where the bomb is. But how do we tell logically if there's a bomb in multiple positions? Given this input, how do you know there's a bomb right here? What's telling us there's a bomb there? We have to think the logic. I can see that, but what's actually telling us that there's a bomb right there? We have a 1 to both sides, which doesn't necessarily mean there's a bomb, but doesn't mean a bomb because we have a question mark. Yes, that's a wonderful question. How do we translate from brain logic into code? Because it's really simple. These are my thinking yoga balls. I always have them. Is it sufficient to say if a question mark has 2 1s on any side of it, then it must be a bomb? Because there's no other bombs on here. So if we just had the 1 question mark, we don't know yet. But if we have a question mark on 2 sides, that means nothing because the bombs could be all on the other side. How do we know there's a bomb? Really, thank you, Sasha. This is what I get. I mean, if I could figure out where the 1 bomb is, then I absolutely know how to get the rest of them. Because I can place the bomb and decrement the count. So let's think that same way. We've decremented the count of all of these. We don't say how many bombs, we say how many potential bombs are left. And we flag them, then we can reduce the count and get rid of them. But we don't know where the bombs possibly are. Or if we take the backtracking approach and just randomly place a bomb, this would solve for all grids, but I don't think this is what's intended. Or do we know? You just... Okay, let's check the tests. 1 line. Okay, this is a good one. Hidden mines. Okay, we should be looking for 1s actually. Any place there's a 1. I'm going to check around it. That makes more sense. If there's no 1, then I think we're in trouble. Yes, exactly. That's you got to my next logic. If we have no 1s, then we're in trouble. But that logic will work otherwise. Except when we get to this test. Or if there's a 2 with 2 question marks beside it. We have that case as well. So we can actually extend the case, say if there's a 1 with 1 question mark, a 2 with 2, a 3 with 3, a 4 with 4, all those cases are solved and we know where the bombs are. Okay? Will this actually work here? So we get a 1 with... We do, because we're actually going to get the 3 case, and the 3 has 3 question marks. And that's going to reduce all these values, because those are all going to be bombs, and these 2 go to 0. So this is actually going to work. Yeah, Zaglev, I think we're correct on that. So we just have to change it. We're going to find anything that matches that pattern. And we don't want to get C. We're going to say Q if Q is less than 1, then we just continue. We skip anything that's a bomb or what otherwise. And now we're going to count questions. Actually, let's put the value here. And the questions are grid.count C, R, count unknown. And we have to write a count unknown function. unknown, and self xi32, yi32. It's going to be an i32, and the result is let mut c equals 0. And for all of these, we're going to say for ix in -1 dot dot 2. Actually, can I do this? Let's find out. And we just don't care about efficiency in this case, since this y minus 1 dot dot y plus 2. If cx, actually just do it here. If cx is less than 0 or cx is greater than or equal to width, then we can continue. The same with y. And this should be a generic function if cy is less than 0. And actually, let's make it a generic function, just so we can see it. Is valid and self xi32, yi32, the bool. Return x is greater than 0 and x is less than width, and self.width. And y is greater than 0 and y is less than self.height. Then we just do these two loops. If not self.is valid cx comma cy, then we continue, we just jump out of it. Then if get self.get, Pythonic self nonsense, cx comma cy equals -1, we say it's unknown. I wish we had a constant for that. Then we could say c plus equals 1. Then we're going to return c. And we're going to scan this forward, and as long as we find a bomb, it means we can restart the thing. And okay, this is going to get really costly in terms of our algorithm is going to be really slow. I hope these aren't too big. We're going to make this return a bool. If qs equals v, now we said if the count equals the number beside it, then we know that it has to be, all those questions have to be bombs. And then we'll return true because we found a bomb. Otherwise, we're going to return false. We found no bombs. And so as long as we do this while find bombs, we'll find bombs. I don't know. We'll see if it accepts that. And so now what we want to do is we want to place a bomb in all the question marks. Okay, so we're going to do place bombs. This is grid. So that means all the things around it and all the surrounding spaces are bombs. That's what we agreed for place bomb. Place bombs at c comma r. Return true. Because we can't have mutable matrices, so we're going to do it inside here. Shit, we can't do this. Russ is going to beat us up again for this. That I can't actually make a function to place the bombs because I already have a mutable matrix, and it's going to take another mutable one. Or is it allowed to borrow it? Let's do this and see if it actually works. Grid and mut matrix at xi32 at y32. No return value. Let's see if we can actually, let's just see if this compiles so far. Place bombs, grid, comma, c, comma, r. keyword 23. That has to be an impl. Self.rooms. 107 is the next error. I really hope so. That'd be great. So C. Alright, oh, we timed out. That's fine, because we didn't place bombs. I just want to see if it compiled correctly. And so now we can place these bombs. And we're going to do the same thing here. I'm going to place a bomb at... Oh, wait, no. If not self dot is valid cx comma cy, not self but grid. If it's not valid, then we continue. So we're just scanning all the places around where we're placing the bombs. And again, we're just going to check the Q if it's actually a question mark. Let v equals grid dot get cx comma cy. If v does not equal -1, if it's not a question, then we skip it. Otherwise, we place a bomb. We do place bomb grid cx comma cy. And this looping is very, I do shows in complexity, and the worst case of this looping is just ridiculous, but it's mostly going to just solve itself. It's not going to do the same thing over again, over and over again. Each time it reduces a bit. So when we place the bomb, it means we place the matrix x32, y equals i32. And again, this is the same loop again, because I got to loop through all of these things. Actually, I'm going to copy the whole thing. And if I knew Rust a little bit better, I'm positive there'd be like some sort of visitor I could do that repeat this pattern. So it'd say for each one, and I could pass a function in, a callback with a lambda that would do this exact same thing. And that would be ideal. So now we're placing a bomb at x comma y. And we're going to say grid.set x comma y as -2. It's a bomb. So we need a set function. Y i32. V is i32. So we return a value self.rooms y times self.width plus x as use size equals value. So we're going to set this to -2, and we're going to say if the value is there's an error condition. If the value is not greater than 0, we probably made a mistake. So if the value is less than 0, less than or equal to 0, we continue. We probably made a mistake. Otherwise, grid.set cx comma cy value -1. Now the logic here is when you place a bomb, the question marks beside all of them go away because there's less values. So if you place the bomb, then there's 0 questions left beside it. In this way, we can step through and keep reducing the count by 1. And we break out of here to let it start again. Each time we find a bomb, just let it start over so we can always find the ones. And let's see if this just takes too long. Or we get errors. Yeah, and I knew something like this was coming. 42. But it's okay. And it worked. Got them in order. That one worked, so that's great. I hope you understood the logic of what we're doing. Pretty sure Zagiev there did, but if you don't, just ask. Found nothing, expected 4-3. Oh, let's see what else we have. We're going to test the other ones first. So we only did the test case in the first one, so our logic is broken. And let's look at the test cases. What does 2 have? 2 has... We went through and we looked for the 1, and so we should have found one with 1, and we should have placed a bomb there to reduce this to 1, this to 2, this to 0, this to 1, and this to 1. So we should have found it. And let's figure out why we didn't find it. Our logic, I think, is correct. We just implemented it wrong. I like saying we when we made a mistake. It makes us feel as though it's not just me that made a mistake. A function that takes the functions. Alright, so if that's simple, let's try getting this working first and then rewrite it to see that, because I really want to learn that. And it's something I do a lot in other languages, and it's something we really have to know here. Alright, let's so first check this logic here. If we ever find one that matches, we have a place bomb. And place bombs, and we know which one should match. So we know which order these should work in. Print air place bomb at place bombs x comma y. And let's see where we place the individual bombs. And we're just going to do this to verify our output, see if we're doing anything totally wrong. Now, how do we check this again? We want to do hidden mines. The first bomb we'd expect place bombs at 2, 1, which is right here, which is what we expect. We expected a match here, and we're placing a bomb at 3, 2, which is right here. Perfect, that's what we wanted. We placed a bomb there, and the next one place bombs is 2, 2, which seems a bit weird. We should have found a different one first. But we placed a bomb at 3, 3, which is the down here. I might just have our ordering backwards, and I think we're missing a bomb. Okay, so we're missing a bomb there. There are 6 bombs and we output 4 of them. Why are there 6? Oh, that's mean. That's why they give us the number. We have to check at the end. If the number of question marks in total has the number of bombs left, then we're going to just fill them all in with bombs. That'll fix this case. Doesn't seem like a nice case. Does it seem like a realistic... Is that the correct way to solve this one? Try and think. So I'd mark this as a bomb, and then this one would have to be a bomb as well. And those would have to be bombs, and these have to be a bomb. And that means there should be a bomb there. But there's nothing to mark this one. So these 2 are the ones I'm missing, because we have no way of marking them. We have 2 bombs left in 2 positions that could be bombs. So that's what we have to test. Every time we find a bombs, we're going to say number of bombs minus equals 1. If NB is greater than 0, like just fill the rest of the question marks in with bombs. That seems fair, huh? That would solve that problem. Place, bomb, grid, R, C. Just fill it in bombs. That's really sad. And mut, grid. Okay. Alright, they have to fix this editor. This is getting annoying. Every time you run it, it goes to the top, because it doesn't know how to parse the thing. Huh? Oh, yeah, if grid.get r comma c equals -1, then we should just place a bomb there. Make it simple. Okay. This is cheap. This is a cheap way to do it. I just say finish it. Okay, we have an index out of bounds at 51, but the bounds is 51, so now we have an issue here that we screwed up line 3. What about the final test? Okay, so we have an issue there, but let's get back to that one. Let's get this one first, line test 3. Make sure we haven't broken the first one. Good. Hidden 1, fine. Test 3. What is the one-line one? We have an index line 51. We have an issue here. The index. Where do we get that index out of bounds error? We have it at line 39. Which makes sense. Which actually means line... I think we are marking spots as not bomb. Oh, I see what you're saying. If the count is 0, we don't actually place a bomb, we just say not bomb. Let's cover that case first. So if there's a question mark, count unknown, right, I think we'll get back to that, but I think you're absolutely correct. If there's a 0, and there's... No, it doesn't make... We're going to have to do it a different way. We're going to have to do that a different way. We're going to have to go through in all the question marks. If there's any zeros around them, if there's no numbers, then they become 0. Yeah. Yucky. Okay. Let's try to fix this first, though, this index out of error. So we have it at... Yeah, I'm thinking we don't actually... Yeah, how did that first test actually work? If we take a look at their code, we have exactly that here with this question mark. Our current code will not get rid of this question mark. It could be this last one that's failing that's doing it. But let's get back to it, because my first problem is not actually that. It's in this matrix 159. RC grid dot width grid dot C comma R. Make sure you get those right. And screwed up one of them. I wonder how many places I screwed that up. Okay, let's check this again. This one still works. Oh, we're failing that one now. So we have a weird question mark. Yeah, let's check line 3. I think this one, we have to solve this one. And what are we emitting? 0, 2? Which probably shouldn't be a bomb. The only one it should identify first is place bomb at 9, 1. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's identified one right here, and that's correct. That's the place where it's supposed to put the bomb. So it's put a bomb at 8, 2. I think that's correct. So after the first step, let's emit the grid each time. Is there a simple way to emit the grid? There is. There's going to be a really simple way to emit the grid. Print air. We'll just put an extra line here. Let. I just want to print the grid out. I should probably make a helper function, but I'll just do it this way. If C equals -1, and then we do a... How can I do a print error without putting a print line? Just do it this way. So print error line, and it should just be print. I assume there's a right, and I'm hoping that works. So we're going to look for print error line. And I'm not so talkative right now. I guess it's getting a bit quiet, getting a bit late on this, but that's okay. Print error line, and then we do a print error. -1 we said is a bomb, so let's mark it as a bomb. Else if C equals -2, print error. No, these are the bombs. First ones are the question marks. Else if C equals 0, just to match their inputs, we'll put a dot. Print error dot. Else print error comma C. These are all these. Yeah, okay, that was because of the stupid search feature not working. After each one of these, we print a new line as well. We've got this backwards. R height. Okay, so after the first one, we got rid of this 3. We got rid of the 2's. And that was expected. I said, what happened to the other ones? Oh, now we have a variability. Not that one. One line. So we fixed that, we got rid of that, and now we have this ambiguity bit here. And this is what I feared. We have an ambiguity. We have this bit to resolve here. We have 2 1s here, and we have 2 1s here. Now, we know logically the only way this could possibly resolve is if this one is the bomb. Or that one. And that one. And so this is the Fear case, and this is what I said right at the start, is that the complete correct test for here is going to involve backtracking, and I don't know if there's a logical way to solve this one here. Is there a logical way to know which one is the bomb here? Can we just look at this and say this has to be the bomb and that other one has to be the bomb? Because we have a 1 here, and we place some more bombs, we just fill them all up. And if this is one of those things, the only way you can really do it is just fill one in and check for inconsistencies. But I don't really want to do that. This would be a second one I failed tonight then. But this is really hard because okay, and this one here found 0, 0, expected 1, 1. We might be okay with this one. Let's try this one first. 4 is looking like 2 blocks. This one should be solvable. Let's do a print grid. Let's take this and do a print grid. Print grid and grid. And we can print it and see what happens. And print grid, grid, and matrix. Yep, go away. Let's do it as at the start as well. The print grid at the start is just so we see what it looks like. So we found a bomb. We found both of those as bombs, and that makes sense. So there's a bomb, and all those ones go away. And I think this is what Zaglev was saying, that now we have a question mark with zeros beside it. If there's a question mark beside a 0, yeah, thanks, Sasha. I mean, lots of. If there's a question mark beside a 0, it means there cannot be a bomb there, because otherwise there would have been a 1 there. Right, so that's what we have to fix too, is we have to start placing zeros. And we can do that in find bombs, because it has to be recursive. So if this first thing here in find bombs didn't find a 0, now we have to look for a question mark that has a 0 beside it. So we do the same loop again. Start with that. If v does not equal -1, if we don't know what it is, continue. Now what we want to know is if any of them are 0. And if any of them are 0, it means we have to clear this one. So let's do this again. Let's do, let's say replace question beside 0 with 0. Find known bombs. And I had to do this loop again. Function has 0. Grid and matrix xi32. Alright, see you, Studiosity. Have fun. I'm almost done this one, but yeah, I'll see. And I might want to do the inline functions on it after, or maybe tomorrow I can add them back in if we have a better solution. But let's see if I'll set it first. Anybody with there, it's just bear with me, it's getting a little bit late, but let's try this one out. I think I know the solution for this one now. We're going to do this, and if it's not valid, continue. If v equals 0, then return true. Return false. Bool has 0 has 0. If hello IKSF, you're joining us rather late. We're in the middle of solving bombs, you know. We were done crashing things into Mars, and our war game didn't work out so well. I'm blaming ambiguities in the rules. And grid, comma C, comma R. Then we actually have a bomb. We didn't find a bomb, but we got rid of one. How do I do that now? We needed to keep processing when this happens, but we didn't actually find a bomb. So we're going to do grid.set c comma r to be 0. And we're going to actually have to take a bomb count. Number of bombs, as they called it, which is not so nice, I-32. And right here we're going to say number of bombs minus equals 1. Minus equals v, actually. We replaced all those bombs. And mut-nb. As long as we keep finding bombs, we're going to keep doing it. Let's try the first one again to make sure it's sane. We got an error. 236, unclosed delimiter. Okay, function has 0. Let's see what that is. Function has 0. Bool, this is... What's wrong with has 0? Anything wrong with that? Grid and matrix x, y. Unclosed delimiter somewhere. We're having fun looking for unclosed delimiters right there. Cannot use minus equals and mut-I. Huh? So a rush dual issue? Why can't I do this? Oh yeah, dref. Yeah, okay. Thanks. dref. Where did I put that? I really wish it'd stop going to the top every single time. Like this, minus equals. Well, thanks. I needed that because I would have looked a long time for that. Okay, so we're placing bombs. Placing bombs. We're not placing bombs. Okay, we solved the first two. Let's try 4. We were trying to solve 4. 4 actually works. That's the one we're trying to fix. And 5 actually works. So what have we done wrong on 3? 3. Come on, 3. 3. Hey, we found different bombs than they did. Is that good? Is that bad? We shouldn't need this loop now. Let's check this. We shouldn't need this. Because we get rid of all the question marks. That's an ambiguity if there's any left. Oh no, we needed it for the hidden ones. Okay, so ignore that. Needed for hidden bombs. See, the only one we don't have working now is 3. And it's because we have a disagreement in where the bombs are. So we have these question marks here, and at the very end, we have those there. Does this satisfy it? Just curious first. If you had a star in the first one, that would be 1. And that would be 1. Then you have 2 empty ones, and you have a star in the next one, that would satisfy that 1. Actually, I'm going to copy this to a text editor. Copy this over to here. Proportional fonts, so let's put it into a console instead. Or can I toggle the font quite quickly here? One time in life I actually want, you know what? Let's do it up here. I know this will work. Put it there. It's probably going to mess up. And then we have the bombs we know are right here. Is this a valid solution? Before we double check it, let's make sure this is a valid solution. So this is 1. Okay. This is 1. Good. This finds 1 here. This finds 2. So no, it's not a valid solution. we've actually come up with an invalid solution here, and we have to figure out why we've come up with an invalid solution. What do we do? The first bomb we placed is there. It gets rid of the 3, and it gets rid of the 2's, because it placed the bomb and gets rid of the 2's, and reduces it to 1. I think that's okay. I think our question mark replacing with 0 is invalid. Because what ends up happening, our logic for 0 is a little bit off. We know these are zeros here. If there was a bomb here, potentially this would still have a number in it. Because it has no number in it left, it means there's no bombs here. Huh. Does that make sense? I'm looking for the logic there. We only have one that fails now. We must find a way that can do that. Thinking how to convert that logic again down. We have... How do we know there's not a bomb there? What logic is telling us that? We've placed the bomb. We knew where the bombs were. And those numbers are decremented because we found a bomb nearby. And we know there's no bombs beside there because that's what the 0 says. I'm trying to think this logic in my head. Something we have broken here. 0, 1. Is this a consistent state right now? No, because when we placed the bomb, it reduced the number. If you place a bomb beside an unknown position, it means nothing. It could still be a bomb. But when you set this to 0, all the question marks beside it should go 0, but that would have a cascading effect down there, which doesn't make sense. So we place bombs at 9, 1 right here. And all 3 of these become bombs. We know those become bombs. And this becomes... That becomes 0. That becomes 0. That becomes 0. That becomes 0. That becomes 1. I think that's correct. I think this is a correct state. So this is the correct state we have here. We know there's your bombs. We don't know about this one. But because of that 0 there, this should also be 0. And I'm just trying to think of why... There has to be some logic here saying, why does this not cascade down? If we don't know what's on either side, this has 1, 0. And this has a 0, but we don't actually know what that is. Because it could actually be... I'm trying to think this is, how do I actually do this? I logically know this one's a 0, but the one beside it is not. And why is the one beside it not a 0? it could be a 1, because we don't know about the one on the other side. Dum, 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 dum. Yeah, that's what it's looking like. Not bomb is not the same as 0. Do we have another state then? Alright, let's do another state then. -3. God, I need to learn the print grid. And we're going to put a -3 in here as well. I'm going to put a minus. It's not a bomb. And when we're stepping through the grid and we find the ones that are beside 0, we're actually setting them to -3. It's not a bomb, but we don't know anything about it. It's not a 0 either. And it worked! My printing didn't work, though. Was that it? It works! Excellent! So that all it took is saying not a bomb is not a 0. Alright, so Zagyev, let's look closely. Since this works, and since you know how to pass a function to a function, should we clean this up before we submit it? That is, do you know how I can make an iteration function on matrix that takes a function and a lambda? I want to encapsulate this logic into code, but I'm very happy this works. We got it working, and this is a lot of code for that, and mostly it's repeated code. And what we want basically, thanks Sasha, we managed to do it. How to pass a functions argument. Well, these take lambdas. Where? Let's see if we can clean this up before we submit it. We don't want to have total garbage always submitted, so let's clean this up so we have at least one thing submitted that's not ridiculous. Let's do the count unknown first. So what we want on the grid, on the matrix, is we want to have a up. What's up mean? So let's do enum cell up on version 1 point. So we want it to look like this. We have F, and I don't actually know what that means. Okay, let's go. So we have enum sum on, we want to have a callback, simplified generics. This is F. Enum cell F. Moving into another line where yes, I'm going to need to capture state here. Where F is function I think I just need I32 to nothing. It's just fn, I think. And so now I want to call it. I want to do cb self.get cx comma cy. That's what I want it to look like, or I guess something like that. And now we have to rewrite this count unknown. Count unknown. I should count. Let's paste, copy it first. So the question is, how do we do the lambda now? We want to do self.enumCell x comma y and something here, some sort of lambda. This is an I32. This is a v, I32, count unknown, c plus equals. Okay, now we have if v equals -1, then we say c plus equals 1. Now we're just going to fight with this until we have the structure correct. Turn C. Alright, line 74, no surprise. Which one has to be that? Wow, these errors are terrible. 74. Let's stick with 74 first. That's where most of the errors are. Line 74, this is not a function. Unexpected token. What does that mean here? Expected type. Oh, it's just because there's no type. No return value. Let's try that first. Let's get to an error somewhere else. Now we're on line 78. Too many of those. No. Yeah, we need a line. End of the statement. Unused. Cannot assign. So if you just use it inside the capture, got it. So this has to be a Mutterfen. Funmut. You said Funmut, not a Munfutten. Rest the language with the most exciting names. Funmut. So we have fun dogs here. Cannot borrow mutably. Mut-cb enumCell. Is this a mutf? Oh, come on. It suggested mut-cb. I did that once before and it got confused. I honestly don't understand when I put the mut here and when I put the mut here. But this enumCell actually appeared to work. I'm going to play all the test cases again. And it actually looks good. So our count unknown is a lot simpler now. Because enumCell goes around each cell. Now the second one we have to do is, this is also an enumCell. Self.enumCell, no, grid.enumCell. X comma y, and this does it on both sides of it. And now we're going to take a vi32. Oh, we need the full size though. We need to know what this is. This is a I32, I32, I32. Can I give these names here? Or is it just going to X, I32, Y, I32? Grid, enumCell, and we're going to say, we've already checked if it's valid. And we already have the value. This will replace it if we actually, we're not going to take any chances. We're going to put a return here instead. And I have a strange feeling this is going to fail because of the mutability requirements here. CX, CY. Expected 3 parameters, 67. CX, CY. Yeah, this is my fear. We're going to hit this stuff again. Is there any way to do this? Is there any way to modify this grid inside a closure on the grid? Because it's going to be the exact same thing. I'm going to have a closure here calling a closure again. And they're absolutely forcing me into this functional style then. I have no choice but to like temporarily store the values, temporarily get them out, but okay. And mut-self. Let's try that first, see if that actually, that doesn't care anything. Alright, so we have to make 2 versions of that function. Can I make 2 versions? Will this actually, can we overload this way? Or is it going to complain with an overload? Duplicate definition, so let's just give it a mut-enum cell. Mut-enum cell. Doesn't care in that case, so mut-enum cell doesn't work. No, I don't know about that. Okay, I won't get that. Okay, Zagiv, let's try that approach then. So you're saying if I take mut-enum cell, because I want to pass this back, I should be able to pass it here as well. And mut-self. And this is a, what is this? This is an ant-mut matrix. So then I don't have to capture it. Then I have a grid and mut matrix packed in here. Okay, 79, I cannot re-borrow. I'm already borrowing, so I get rid of this. Self is already borrowed. Okay, so that actually works. It's a bit frustrating to do, but okay. If we need to modify, we do it that mut-enum cell, but we actually have that now. And this code probably is there any way, okay, that's what I was just about to ask, and I just do this even with the mutable ones? Well, I'm going to find out. Yeah, perfect. Okay, let's see if they all work. So we placed the bomb, we grid set it, we grid mort-enum cells, and now when the place bombs we're going to do the same thing. Thank you. And so this one has to do the same thing. We're going to grid mort-enum cell, and I'm going to copy these. It's very similar again. And if v is not equal to -1, then we can return. Otherwise, we want to place the bomb at grid CXCY, and that should be enough to mutate it. And we didn't even make an error that time. Just sanity check all these tests again. Okay, that looks good. I want to get rid of these return statements here and say if v is greater than 0, then we'll set it. If v equals -1, then we'll place the bomb. Check that again for syntax. Right, this is looking a lot better. Has 0, then we just need the mut cell. And equal false. Grid dot mut or enum cell x comma y and cx comma cy comma v. We have v. There's no way to early out here, is there? So we have one efficiency loss due to this. I don't care about it though, to be honest. Because in our old version we'd actually early out, and now we don't. Let's make sure that's still working. Has 0, 121. What's the issue here? Forgot the semicolon. So I'm being paranoid about running these tests because I don't really know the language still so well. Then we have one more we can reduce, and this is, like I say, starting to look more and more functional, and find bombs. And this is going to be grid.mut-enum cell. No, this is a different one now. This is yet another one where we iterate over the whole grid. Not mut-enum cell, but mut-enum grid. And fn mut self mut cb, where f is function mut, I32, and mut matrix. And we want to do it across C first. Is that how we said it? We're going to go for each row first. We did it column-wise. Before I do that, I want to see if I can check the order, change the ordering to be not column-wise. That is, do we get the same result? I would hope so. We get the same result if we do the rows first. Where is that? it should be the same result, in which case we want to do row major ordering instead. Alright, thanks for the help with the lambdas. I'm going to just finish this off and publish it so we have like one nice example of code that doesn't look retarded. And just so I finish playing this, but I think this is the last thing I'm going to do as well. And I want to do the last cell. This is not a huge gain by doing this, but we might as well. And we're actually going to pass the value as well, because I see a lot of them, it saves a lot of effort. And somehow I'm too far in the lines down. Don't know why. Everything is off by 1. And we're going to do CB C, R, self dot get C, R self. Grid dot enum multi-num grid. And this, all it takes is a callback where we have R, C, V, grid. Let's see if this still works. Return expected true, found bool 145. Uh-oh, no, I can't do it. That's getting difficult. Because I have to break out here. I would actually have to break out early, so I'm actually going to undo these last steps. Because I don't think you can actually do it. They both break out early, and I think that's, I don't know how to do that approach. So let's just get rid of this multi-num grid. No, that was fine. Those were fine. Okay. And we have some things here, and I think this is, I'm just going to play them all. I think I'm going to be done with this. The negative here, I would like to use a constants instead, but we can learn them a different time. And yeah, I'm guessing that, but I think I'm done with this one. We'll have to learn that one another time. I think we've covered everything I want to here. Let's just submit this. I'm done with this one. Okay. This is actually a really good test, but this is really hard. And that's all we get for it. We got 60. That's all we get. We get 50 XP for one of the hardest ones we've solved, other than the war one, and I think the war one specified wrong. And I think that's it for me to make. It went a bit long again today. If I'm not too tired, I'll do it again tomorrow. I don't want to aim for 3 hours. I'm trying to do 2 hours. We got stuck up in the war thing a bit longer than I expected. It shouldn't have taken so long. But I thank you very much for watching. We got the test of the week done. Maybe we should do that every week. I don't know about these challenges. I think I still like the challenges. The one with graphics are fun to do, but I don't know what else to move on to here. And the purpose of learning Rust was I'm mainly just going to walk through the challenges, and I'm forcing, I guess it's we're forcing ourselves to use more, like the lambdas and all this stuff, so we're going to over-engineer the challenges, but I think it's a good way to go. Yeah, for exploring Rust, I think that's legitimately true. You don't get very far in Rust with these types of challenges. But what I'm hoping for is if we get to the hard ones, or if you start seeing with what I did for war and stuff like that, we're going to try and just force it. That is, I'm not necessarily interested in completing all the challenges. What I'd prefer to do is actually just take it and say, look, let's find the ideal structure. Let's find any way we can use Rust and any way we can modify this so we use the best thing for Rust. I'm not interested in being the quickest way to solve a challenge. I actually am interested in learning Rust and the way that works. And I think this was a good case for, with these grids here, is if you completely avoided the functions and just passed one vec around, you could easily solve all of this without any of the immutability, without any of the functions. But that's just no fun. So I think I'm going to keep going on this. And yeah, I know the multi-threading is something we're not going to get here. I'm going to have to do it on the side and try something that way. Because I know the whole thing about borrowing and ownership and the data races is that unless you have multi-threading, you've completely lost it. And I don't know. We're going to find out one time. We'll find out if we can use threads. If we can use threads, we're going to force it. We're actually going to use it. And we'll get to the point where we might have to. We'll see what's going to happen. Otherwise, we'll do everything except threads. Because I said this mutability stuff is still a bit new. And it looks like we still have a lot to learn. It's not like I'm running through this without making Rust errors. So we're just going to keep going with that. And I think we'll keep doing more of these mediums next time and eventually get the hard. But I'm still getting stuck on some basic Rust things. And I don't care if I actually finish the challenges themselves. Like I say, the war one, I think there's a problem with the puzzle. But I think that's the way we'll go. I'll keep going for this. And exploring, yeah, we'll see. If you have ideas of things we can use, so anytime you see me doing something, you say, hey, this concept from Rust will work great, let's do it. Do we have another type of match? Do we have another select? Can we do a lambda here instead? Anything we could possibly do to either simplify the code, just to explore a new concept, we're going to do. Part of the show is purpose of learning Rust, not just to play on coding game and to produce some nice solutions and maybe go back in our old code and patch them up. But I think that's it for me for tonight. I thank you very much for watching. Please do subscribe to my channel on Twitch, follow me on Twitter. You can join my group on Coding Game. Make a friend here if you're on it as well. And otherwise, subscribe to me on YouTube. I thank you very much. And yes, traits, I'll look at traits as soon as I can. And then I'll come back tomorrow and we'll see what we do tomorrow night. Thank you very much. And again, thank you very much to Slavomir who's supporting me on Patreon so we can get some more equipment here. And I'll see you all tomorrow night. Thank you.